So if you stepped through main 44, which is the last place where there's a store, you should have seen a stack that looks something like this. As usual, frame pointer pointing at something from before main we don't care about, saved frame pointer right after that, and we now know that this extra 8 bytes is uninitialized data space. Just for the alignment, keeping things aligned to a hex 10 boundary, which is why it went down to F0. But the key thing you were supposed to figure out here is what's going on with the A and the B. And so if you looked carefully about where things are stored, what their particular values are, you would have seen that B is stored here at F's 8E8, and you would have seen that A of 1 is at 7F's 8C0. So that's the A's, that's the other random constant, but why was that constant used? Because A's plus that gives us Balboa bled blood. So the takeaway for this is that it's the same basic arrangement as we saw for scalar local variables. We had B declared second and A declared first, but B got the higher address and A got the lower address. I think we should throw a little bit of chaos magic at it, and what do we see? We see AC.add, compressed add, extra new compressed instruction. So how does that operate? So compressed add register to register is now actually going to be using that implicit to form. So the destination is an implicit source. Source, destination, this register, whatever it is, plus that register, store it back into that register. So for instance, x1 plus x2, store it back into x1. Now this is unlike the RV32i where I said specifically they had to have 3, and so it looks like the compressed is fine with the 2-register form, probably because of the fact that they have so few bits in which to encode everything. And indeed, because of the fact that they go with this 2-register form with the implicit use of the destination as a source, that actually allows them to still specify all 32 possible register values for source and destination, modulo a caveat that basically the RS2 is not allowed to be X0 because that instruction encoding is actually encoding some other instructions. And the final takeaway from this code is that we finally see the use of CADI16SP up here at the top of the code. I said when we saw it down at the epilogue, we'd eventually stop seeing CADI at the beginning because this is actually the more generic instruction, and so it's perfectly balanced, as all things should be. We've got the CADI stack pointer minus 80 at the top for the function prolog, CADI 16SP plus 80 to restore the stack at the end in the function epilogue. So what do we pick up in this section? The new add instruction, simple, add, elegant. And add pops up here to complement our add I, and it also gains a compressed add form.